This is a continuation of the Python built-in data structure lecture. In the previous lecture, we have completed with the list and tuples. And we started with dictionary, but I'm going to come back again on dictionary. And also we'll finish with the set data structure. And all these four are the built-in data structures in Python. So a dictionary, as already introduced, it's a record of key value pairs. Okay, this is pretty much similar to the map data structure in Java. And each item in the dictionary is stored as a key value pair, where the keys must be unique. Okay, so this is the key, for example, name. It must be unique because it is an identifier. And also hashable, so this will allow a quick access to a JSON string. And these keys are immutable elements. They cannot be changed, as contrast to the values, which can take different values. So the dictionaries are mutable. It means they can be changed. I mean, you can modify an existing value, okay, with respect to a certain key, or you can add a new key as well. Okay, for example, here we didn't define address. If you want to add a new key into the dictionary, you can make my dic, and you add the key address, and then you assign a certain value. So the size of a dictionary is dynamic. It can grow or shrink as needed because it is immutable. And starting from version 3.7, they becomes ordered. I mean, when you make a for loop, it's going to start with the first key depending on their order. For example, if you have multiple keys, it's going to start with showing the name and then showing the age and so on. So the access can be done by specifying the key for the dictionary between brackets. Okay, and for example, this one is going to return the corresponding value. We can make an iteration over the key and the values using a for loop. And there are many ways on how to do iterations, but the most common way is to make a for loop and extract the key and the values from the dictionary.items. So this will return a tuple, and you can go through all the tuple values.
When you said that it's ordered and unordered, does that mean upon insertion it's sorted every time?
Yeah, so the last element inserted will be ordered toward the end of the dictionary. So here, for example, if you make a for loop, it's going to start with the first key, second key, and so on. It's going to respect the order. And this is more predictable. So please let your mobile phone. Naif. Okay. So this is just a summary of what I've mentioned right now. We talked about the modification, okay, by updating and changing a current value, and also adding a new pair of keys. So this example shows that the dictionary maintains the order. For example, if you print the key and value pairs, they're going to appear in order, starting by the ID and then the name and then the price. So later on, if you add the color, it's going to be ordered toward the end. So for assigning or accessing the values, as already mentioned, we can use brackets and specifying the key. But here you might have an issue if, for example, the key doesn't exist. And in this case, it will raise an exception. So in order to have a safer access, okay, which also will take into account of the key non-existent, maybe we have deleted the key and so on, to avoid having a key error, we can use the .get. And the .get, you can specify the key and a default value if the key doesn't exist. So in this case, contrast is not defined in settings, so it's going to return no contrast setting provided. And this is better for handling the missing keys instead of raising an exception. So the commonly used dictionary methods, we have the dot keys, which retrieves a view of all the keys in the dictionary. Okay, so you can return all the keys by making config.keys. The name of the dictionary dot keys is going to return this list that contains the list of all keys. Dot values, of course, it will retrieve a view of all values in the dictionary. Like in this case, it's going to return 1920 and 1080. Dot items, since we have used before in the for loop, is going to return a view of the key value pairs as a tuples, okay, in the dictionary. And then you can, so if you need the key or the value, you can implement your logic inside the for loop. So dot update the dictionary with key value pairs from another dictionary. So for example, if I want to update the config that we have defined here, so the config here, it has only width and height. Using dot update, I can add additional settings, not one by one, but I can add as also a dictionary of key value pairs. Okay. And pop is going to remove the items with the specified key. For example, if you make config.pop, it's going to remove this item from the dictionary and will return the item as well. And if the key is not found, it will return default. So the output here, when we make config.pop, is going to remove the height from the config dictionary and will return it as an output. So later on you can visualize it. But if you call it another time, of course, it's not going to be present in the dictionary. And clear is going to remove all the items from that dictionary. Yeah.
Why does the pop take 2 arguments?
Which one?
Config.pop, why does it take 2 arguments?
Oh, I think
It's only supposed to take the key.
yeah. I think there is a mistake in this code. Yeah, you're right.
Is this the default?
Hmm?
The second of the default. 180 is the default. But it didn't find the hard.
That's also, yeah. Yes, this probably to avoid having crashing. Yeah, it returns the default value. No, that's correct. So also, if you want to make conditional iteration, you can use if is instance, for example. You can make an if statement based on the logic that you want to implement on the inside the iteration. So dictionary is one of the most important data structures in Python. It's used in several real-world examples for handling data. So one of the primary use cases for dictionary is data storage and retrieval locally on the hard drive. Because usually when you store these records, for example, you have a record in Python, so you can store it as a dictionary. It becomes very easy to retrieve it even from the local drive. We can save it as a JSON. I'm going to introduce JSON format, which basically share the same thing as a dictionary with just a few differences. But we can save it as a string record according to this format on the hard drive, and then we can load it later on as a dictionary. And this is helpful to store, for example, configurations or store some records from a database. There are databases that are based on JSON documents, like for example MongoDB, SQL databases, and can be used for storing also configuration settings. Imagine that you have a configuration of or particular settings that you want to store them, you want to retrieve them during your application. You can arrange them as a dictionary and save them later on the hard drive as a JSON format, which you can load afterwards to retrieve all your values, the keys and the values. It can be used as a caching mechanism. So caching when sometimes you want to have persistent data on the hard drive. Okay, so you can store it also as a dictionary, so local cache, and you can delete it when you no longer need this data. And the good thing, because dictionary, they have the concept of the keys, which allows you to find, so you can give a semantic name to any variable that you want to retrieve later on. For also creating mapping relationships, so we map keys to values to represent relationships, such as linking product ID to descriptions or names. Okay, so one of the most important relationship of or most important usages of dictionary is that we can serialize them as JSON format. So serialization, usually when we say serialization in programming, it means converting a variable to a string. And we use this usually when we want to send, for example, a variable through the internet. We need to serialize it as a string because we can only send strings as bytes, and then we can send it to the internet. And there are many applications for serialization. So JSON serialization basically is going to convert a dictionary into a string format. And this string format can be saved into the local drive and can be also loaded. So how to do that? We need first to import JSON, which is a built-in library in Python. And then you have a dictionary, for example, employee record. It's a dictionary. You can do json.dumps. And here there is an S at the end. There is .dump, but doesn't do the same thing. But .dumps, it's going to serialize. It means it's going to convert this dictionary into a JSON data, into a string data. And if I want to retrieve the dictionary from the string data, I can use json.loads. So this is very helpful because when you dump the data into a string, you can do plenty of things. One of them is save them into a file. Okay, so we need serialization. One of the serialization use cases is to save the info. You cannot save a pure variable into a file. You need to serialize it first, for example, as a string, and then save it locally, and then you can load it and recover your dictionary later on to be able to access it. Because a JSON string, it's a string. You cannot access using the concept of key value pairs. A string, it's a sequence of characters. So the dictionary will be converted into a sequence of characters. Now, if you want to recover the dictionary structure, we need to load it. We need to load it from the string. And of course, the JSON string must be correct. If there is any error in the JSON string, it's not going to be possible to recover it and get it as a dictionary. So this is what we call JSON validation. The JSON must be valid. Okay. These are just a few examples that you can follow.
JSON.
Sorry?
In Python. Why do we use JSON?
Yeah, JSON, this is like the standard format for any kind of data exchange. If you want to exchange the data between computers, if you want to send a data to a web server, you need to have a string representation. One of the most famous string representation is the JSON format. There is also XML format. There is also YAML format. But JSON becomes like the de facto standard for data exchange over the internet. Okay, so JSON helps you to store, manipulate the data in a structured manner. Okay, and here in these slides, I provide the differences between a dictionary and JSON. So dictionary, they are native data structures. They are built into Python and used for in-memory data storage. This is why we use dictionaries. Okay, on the other hand, JSON is used for data interchange format, to exchange data between, for example, a client and a server. And why it is used? Because it is lightweight and it is text-based format. Everybody can understand. And it's used primarily for data interchange between servers and web applications. So it's basically for network communication of messages. So Python dictionary are mutable. It allows you to change the data after creation, but JSONs are not, okay, because they are string. They are like fixed static string. So the key types supports any immutable data types as keys. So the keys usually they are either string, number, or tuple, because they must be hashable, okay, and they are immutable. However, here in JSON, it only supports strings. String keys are allowed. You cannot make a key that is, for example, an integer. Okay, only strings are allowed. So even if you use a dictionary, a number as a key for a dictionary is going to be converted to a string by adding double quotes. And also another difference in the syntax in the dictionary, we can use single quote like this to define a dictionary. Double quote is also applicable in Python, but for JSON we only use the double quote, okay, to define the JSON. If you use single quote, the JSON will not be validated. And here again the example of JSON.load, and look, now this is a string. Look, this is a dictionary, but it's defined between quotes. Here we use simple quotes because we have double quotes inside, so we don't mess up. And if you make JSON.load, so we're going to load the JSON string and convert it to a dictionary, and then we can do the other way around by converting the dictionary to a string by using .dump. Yes.
Does loads and dumps work with anything other than dictionaries?
No, this is meant for dictionary, okay, because this is the expected format of JSON. Yes. Yeah, part of it. I mean, we made it last week, and you have it also in the assessment. Okay, so this is a table that summarizes the differences between Python dictionary and JSON. So the last data structure that we are going to cover today is the set data structure. So set is also a built-in data structure in Python designed to store unique elements. So like sets in Java or in general data structure, it doesn't allow duplicate values, as you already know. It is unordered. There is no order in the set. It is not indexed. You cannot access a set by a certain index, and it has no duplicate. Even if you add an existing element into a set, it will not be added, okay? It will only keep one instance of each element into this data structure, and it is mutable. It means you can add other elements that are different into the set. So the efficiency of the sets are highly efficient for membership testing, like make them ideal for checking whether an item exists into a set. So usually when we want to remove duplicate from a list, we can simply cast it to a set, so it will automatically provide only the unique elements. And this is how we can create a set using curly brackets. So my set 1, 2, 3, even if you add other elements, is going only to keep the elements that are unique. We can also use the set constructor to create an empty set and convert other iterables into a set. Like for example, I want to convert this list or any other iterable into a set by removing duplicates. We can also use set comprehension, which is equivalent to list comprehension, by using a lambda expression or a for loop to create the set. For example, here I create a set that will take the exponent of 2, or the power of 2, x to the power of 2, for x in the range of 5. And also, we can use from keys. Okay, when you have a dictionary, we can use from keys. It's going to return all the keys as a tuple. And this is pretty much fine because the set doesn't contain duplicates, and we know in advance that all the keys are unique. So it's pretty much the same property of the set. So this is an example showing different ways on how to create sets in Python. We can use curly brackets, so by adding 3 elements, and this is going to return the following output of the 3 elements. And we can convert a list to a set by doing typecasting. And this is the output over here. This is the example of a set comprehension. Is going to return the power of 2 of all the elements. And we have a dictionary. What is the dictionary that we have? Okay, dictionary.fromKey. And then unique set of keys using the set temporary dictionary over here. And this is going to return only, look, it removed the duplicate hello and returned only the keys hello and world. Yes?
Is search in tuples big O of 1?
Hmm?
Is search in tuples big O of 1?
Yeah, because of the hashing.
I know I asked this last time as well, but it doesn't make sense because you said the keys are being hashed, not the objects. But if we search
But
by
yeah,
object-
when you are going to search, you're going to access the key. You're going to search by the key. Okay, so every key would have an index. Okay, when you have hashable keys, and this is why we make them hashable, to speed up the access for the data
So
structure.
we just have to know that there might be, so it's going to return the first one.
Yeah.
And
Yes.
there might be another, but it's going
Yes.
to give the first one.
No, for the set you don't have.
No, in tuples.
In tuples?
Yes. In tuples, if we search by object.
Yeah, searching is going to return the first occurrence always. Yes.
Okay.
Yeah. So how to access the set in Python? You can use looping, you can use a for loop and go through all the elements. Of course, it's completely unpredictable. There is no predefined ordering. Okay, so you can have the elements in any kind of order. Okay, and you can also do membership testing. There is no indexing, as already mentioned. You cannot have an index that will give you access to a particular value. But you can check whether a particular value exists into the set. It's like you want to check whether a key exists into a dictionary in the same way. So adding elements, you can use .add to add a single element to the set. Like here in this example, you can do mySet.add and add a new element. So it's going to return
So can I add in the
augmented
beginning?
set. Huh?
Can I add in the beginning? Because if you add element, it will be added at the end.
You need to create first the set. You can create an empty set and then add
Add in
elements.
the first cell.
Yes. There is no first and last. There is no ordering.
Oh, okay.
Yeah, there is no ordering in the set. You can remove elements by calling the element. Of course, if the element doesn't exist, it's going to be considered as a key. Okay, so it may raise a key error if the element is not found. So this is why you can check the membership first, and if it exists, you can apply the remove element. Okay. And discard element, it's similar to remove, but doesn't raise an error if the element is not present. So this will have kind of safety checking whether the element exists or not. Okay, and output if there is no error. And clear is going to remove all the elements from the set. Of course, I have given you a notebook. I hope that you went through the notebook. It contains all different type of configurations about these data structures. Okay. You can also apply advanced operations like union, intersection, difference, and symmetric difference by just calling any of the function to the set. So if you make the union of the two sets, it's going to create a new set but doesn't contain the duplicates from these two sets. So these are just examples. I put as many examples so later on for the review to check all of them. But let me jump to the last part of today's lecture is about the main concept of object-oriented programming in Python.